Hello everyone. This video goes along with section 2.3 from Math in Our World. Today we want to look at a use for Venn diagrams, which is studying set operations. Now this is a visual method to study sets, and in our examples we'll look at 2 or 3 different sets, but if you wanted to apply this in a larger sense, this would be useful for a study which involved maybe hundreds of sets. And there are some things that you can learn from looking at a Venn diagram or a picture that maybe aren't apparent if you're looking at a description of the set or a list of its elements. So here's an example, and you've all probably seen these before, a Venn diagram with overlapping circles similar to this. And what we want to do is just kind of draw a picture which represents, in this example, the 4 basic set operations that we've learned so far. So first we have A intersected with B. Well, you may remember an intersection goes along with that keyword and. So an intersection is, the elements in there would be elements that are in A and also in B. Well, if you look at this diagram, we have 4 different regions that have been labeled here. So when you have 2 sets, there are 4 different options for where an element could be. One of them is it could be in A and also in B. Well, that would be this region 2. Right? So the corresponding picture for an intersection would just look like this. All right? And we shade to show which elements we're talking about. All right, how about A union B? The keyword that goes with union is or. And for an element to be in A union B, it needs to either be in set A or in set B. And we also said that that's an inclusive or, so it also includes elements that are in both A and B. All right, well, that's regions 1, 2, and 3. So we would shade all 3 regions to represent A union B. All right, how about A complement? You can kind of think of maybe not as a keyword. These are elements that are not in set A, and we have 2 regions. Region 3, those elements are not in set A, and also region 4. So to shade A complement, you would shade everything that is outside of circle A. All right, B complement would be everything outside of circle B. Okay, and then how about A minus B? Right? These are things that are in A, but not in B. All right, so looking at the 4 regions, they have to be in A, so they have to be in regions 1 or 2, but then to not be in B, we don't want the ones that are in region 2. So A minus B is just region 1, like that. All right, and then another example, if we did B minus A, elements which are in B but not in A, that would be this region. Okay, here is a picture of those 4 basic diagrams if you need a review of that to go back to. Right, that should be an intersection symbol. All right, so we have intersection, union, complement, and difference. Now, your book goes through some examples which build on that and also use the order of operations for sets. So let's try to remember that. First we do parentheses, and then complements, and then intersections and unions in either order. So it could be a union and then an intersection. You kind of just go left to right. Alright, so draw this example. Draw a Venn diagram to illustrate the set, the complement of A union B. Alright, well, I see 3 operations here. I see the parentheses, the union, and the complement. So I would do parentheses first. So what I need to do is figure out what to shade to represent A union B. A union B. And then that takes care of the parentheses and the union. Alright, and then I would finally do the complement after that. Alright, so let me give you 2 options for how to do this. One is just more visual. You can either shade as you go along or make some side pictures to represent these different steps. All right, so A union B, that's one that you can memorize. That always looks like this. Okay? All right, so that's step one. We know what that looks like. And then secondly, we need to find the complement of that. Well, in other words, just shade everything in the universal set, everything in this whole rectangle that's not shaded right now. All right, so I would shade out here. And that's the complement of A union B. In words, we could say that would be elements that are in neither A nor B. All right, now a second method, if the visual is not your favorite thing, we could do this using the listing method that you've already done for working with sets and set operations. All right, so what I want to do is just now list out the different regions which make up each of these sets. All right, so the universal set is made up of all four regions, 1, 2, 3, and 4. All right. Now, I don't really like this notation for one reason. It almost looks like I'm saying that the numbers 1, 2, 3, and 4 are elements of the universal set. Right? But this is the notation that your book's chosen. So in this context, it's not saying that these are elements, but it's just saying that these four regions together make up the universal set. Maybe a better way to say it would be that the universe is the union of all four of those region type sets, but that's just a little bit longer way of writing it, so I think your book chose that listing type method. All right, so we'll stick with this. Then set A, all right, which regions are part of set A? All right, that's regions 1 and 2. And then set B. B is made up of regions 2 and 3. Okay, now one thing I wanted to point out is that you'll notice that we have a U and a 4 in this sort of outside region, and I want to make sure you remember, or maybe you're hearing this for the first time, that the universal set is not the same thing as that outside region. Okay, so it's, again, a little bit confusing that the U is written inside the rectangle. Maybe you want to just think of it as like on the edge or labeling it somehow. But you can see from this list, the universe is all four regions, whereas region 4 is just the outside one. All right, if the problem said shade the universal set, then I would shade all of this. Okay, so now we have the regions designated into each of their sets there, and if I wanted to find this, I still need to know this order of operations. But now I can use sort of a listing method. So the first thing I would do is find A union B, just like before. A union B. Okay, and using the listing method, you might remember you look at the two sets, the list of elements, and then you just list all of the elements in either of those sets. Just throw them all in there together. So 1, 2, and 3. Okay, and then the complement of that, all right, the way to do that was to look at what it is we're taking the complement of, 1, 2, and 3, compare back to the universal set, cross those things out, and see what's left. And we're left with 4. All right, and then that's it. That tells you what region to shade. So notice it's basically the same steps, just two different ways of looking at it. One is just shading the steps as we go along, or just in your head sort of thinking about what would be shaded. And then the other method here is this listing one, so that you can have in writing very clearly what number regions should be shaded. All right, let's try another example. A intersected with B complement. All right, so order of operations, I'm sticking with those. So first thing I would do is, all right, the complement of B. All right, so shading, that would be outside here. All right, or if I did the regions again, I can make my list. I know B is 2 and 3, and I'll put A here. We don't really need it on this step, but we might next. A is regions 1 and 2, and then U is 1 through 4. Alright, so B complement, I compare to the universe, and I cross out anything that's in B. So I cross out 2 and 3, and I see what's left, which is 1 and 4. So I've listed here 1 and 4, and then in the shaded version I have shaded 1 and 4, so same thing. Alright, and then I need to intersect that with A, that's step 2. A intersected with B complement. So if you're doing this visually, you would just look at what's shaded, and you would see what part of B complement is also in A, or where it overlaps with A. Alright, well, region 1 is the only one that overlaps with A, so I would erase everything else. Let me do that now. Alright, I would erase that outside region, and I'd be left with just this region shaded. And if I did this using the listing method, I now have, B complement, and then intersected with A. So I would look at this set, B complement and A, and I would see what they have in common, and it looks like there's a region 1 that's listed in both. And that tells me to shade region 1. Okay, let's try one with 3 sets. So now we have 8 different regions, but we'll do this the same way, just using order of operations and the definitions of sets. Alright, if you did a listing one for this one, the universal set is now made up of 8 regions. 3, 4, 5, 6, 7, 8. A is made up of 1, 2, 4, and 5. B is 2, 3, 5, and 6. And C is 4, 5, 6, and 7. And then we have that 8th region that's not in any of those 3 sets. Okay. So I would do parentheses first, which is B intersected with C. Alright, well, visually I can see that that's right here. Alright, and using the listing method, you're going to end up with 5 and 6. Alright, so you're comparing sets B and C and seeing which regions are listed in both. Okay, now I need the complement of that. So using the listing method, I would go back to the universal set and cross out 5 and 6 and see what's left. 1, 2, 3, 4, 7, and 8 are the visual method. I would shade everything except what I had previously shaded. Alright, and either actually shade or just picture what that would look like. Alright, and then I need finally, alright, so I've done parentheses, then complement, and then finally I do intersection. So I need to intersect that with A. Okay, so using the listing method, I would compare this set with A, see what they share in common, and I see a 1, a 2, and a 4 in all 3 of those. So I need to shade regions 1, 2, and 4. Now visually what I'm doing is just looking at what's shaded and seeing what of that overlaps with A. Right, so not any of this stuff. Right, just these regions overlap with A. And sure enough, that's regions 1, 2, and 4. Okay, so that would be my final answer, to have those 3 regions shaded. Alright, try this one. Okay, you might want to pause. All right, we'll go over the answer. Okay, so we have A intersected with B. That's here. The complement is everything else. And actually, I might even just circle the regions we're talking about. Okay, those are A intersected with B complement. All right, and then union C. So to union something, you just combine or put everything in. All right, so I have listed here, I've already circled the regions in this half of it, A intersected with B complement, but then I also want to go back and include any regions that happen to be a part of C. Well, I have 3 of them already circled in set C, but I also need to circle this 4th one, region 5. Right. So your final answer would be everything shaded except for region 2. Okay. Now I usually get at least one question. Somebody usually asks, why is region 5 included? Because that's not part of A intersected with B complement. So remember, for a union, it doesn't have to be in both. It just has to be in one or the other, or it could be in both as well. That is an option. All right, so an example in words would be, let's say that you have a cat or a dog. Well, that's a true statement if you just have a cat. You don't have to have a dog as well. You can just have a cat, and then that would be fine. Right? If someone says you can fly on, you can take this flight if you have either a passport or a driver's license. Okay, and you just have a driver's license. That's fine. Right? So anybody can enter that flight who has one of those 2 things. All right, so here we have selected region 5 because it did meet one of those 2 requirements. It didn't meet this first one, but things in region C or in region 5 did meet the second one, so those should be included or shaded. Okay, one other final example to do. Let's talk about locating elements in a Venn diagram. So the goal here, given this universal set, we want to draw a Venn diagram and organize all of those elements by placing them somewhere in the Venn diagram. Right? And we want to place each element exactly once. Place once. Right? So for example, we see here element T happens to be in all 3 sets, A, B, and C. We don't want to actually put it in the diagram 3 times. We want to just place it in one spot that shows or represents that it's in all 3 sets. Okay, so draw your Venn diagram and then draw 3 circles to represent those 3 sets. A, B, and C. All right. Notice capital letters again for the names of sets, and then lowercase things would be elements in the sets. Okay, and then you want to go through. Now, one thing I like to do is sort of start in the middle and work out. So I would look for things that are in all 3 sets, and then I would start looking for things which are in just 2 of the sets, and then go out from there. Another option would be just to start in the universal set and figure out where Q should go, and then R, and then S, and T, and just go in order like that. Alright, so pause if you want, try this on your own, and then I'll put up the answers. Okay, here's what mine looks like. So you'll notice we do have element T is in all 3 sets. Elements S and R are in A and C, but not in B. So I've placed them in the spot where A overlaps with C, but does not touch circle B. We have some other elements. For example, U and Z are in exactly one of those 3 sets. Oops. Okay. Then Q, W, and Y were still in the universal set, so they needed to be included somewhere in this diagram, but they weren't in A, B, or C, so we put those outside somewhere. And you could put them, over here or wherever you choose. All right, and then also the other thing to notice is that we do have an empty region, so that may happen as well. You don't have to have an element in every one of these regions. And also notice it's okay to have more than one element in these regions. Okay. Now at the beginning of this video I talked about one of the uses for Venn diagrams is to visually see some different properties of sets that might not show up in a list. And now this one, maybe you could tell just by the given list that there wasn't going to be anything that was only in set B, but maybe not. And maybe if we had 100 different sets, maybe that certainly would not have been obvious. If you had hundreds of overlapping circles, and maybe from a list you wouldn't be able to pick out one tiny little region that was empty, but we can see that from this diagram. Okay, I hope that was helpful. Let me know if you have questions, and I will see you in the next video.